Alright, so in this video we're going to be going over how to find roots of equations. Alright, so let's first talk about what are roots. They're sometimes called the zeros of a function or an equation, but they are the point on the graph where it crosses the x-axis. And this can happen more than once. So visually, if we have this coordinate plane and a graph that looks something like that, everywhere where it crosses this x-axis, that's going to be a root or a zero of the function. All right, so in this case, you'd have 1, 2, 3, 4, 5 different roots or zeros of your function. So the best way to find these is I just like to remember visually where these are occurring and then ask myself, what is the value of y at these points? All right, so if we look at it, this point here is going to have some x value, which is going to be our root, and y equals 0. Again, x 0, x 0, x 0, x 0. All right. So again, in all these locations, y equals 0. So we can plug 0 in for y into our original equation. And solve for x. All right, so let's look at an example here. If we've got the function f of x equals x squared minus x minus 2. The first thing you want to do is plug in 0 for y, or in this case f of x, because f of x replaces y. So 0 equals x squared minus x minus 2. And now we've got to solve for x. So to do that, we're going to factor this equation. All right, so when you get really good at factoring, you can do it pretty quickly. But just as a quick refresher, if you've forgotten how to factor, the first step you want to do is multiply this number here by this number here. So this is going to be your A and your C. So you're going to multiply those together. So in our case, we've got 1 times -2. So that's going to be -2. So now I've got to find two numbers that multiply to be -2, but add up to be this middle number here. So in our case, a -1. So Factors of -2 would be 1 and 2. Now they've got to multiply to be -2. So one of these has to be negative, but they've got to add together to be -1. So I know that this has got to be the negative, and this one's going to be positive. And then I can just put these into parentheses. You start with your x and your x, and then a +1 goes on one side and a -2 goes on the other, which is what we got here. And then we can just set each of these individually equal to 0. So x equals -1, x equals +2. And these would be the roots of your function or equation. So go ahead now and try on your own. This one right here. If you've got f of x equals x cubed minus x, and find the roots. All right, so go ahead and pause the video, work that out on your own, and then you can check your solution in the PDF below. It's going to be number 1. Let's go ahead now and look at another example. If we've got f of x equals x squared minus x minus 2 all over x plus 1. Again, we're going to set it equal to 0, so x squared minus x minus 2 all over x plus 1 equals 0. Now we're going to factor the top, which we did above because this is the same equation. X plus 1 minus 2 all over x plus 1. Now this here can cancel with this here, and we're left with x minus 2 equals 0, so x equals 2. And it's important to note here that x cannot equal -1, and that's because our denominator here can't equal 0, otherwise it would be undefined. So you'd set the denominator equal to 0. So x equals -1, but the denominator can't be 0, so x can't equal -1. All right, so go ahead and try on your own. F of x equals x cubed minus x all over x minus 1. And find the roots. So you can go ahead and pause this video now, work that out on your own, check your solution with number 2 of the PDF below. All right, and then finally, one last example. Let's go ahead and find the roots of f of x equals x squared minus 12x plus 1. Now you'll notice that this one can't really be factored, so we're going to go ahead and use the quadratic formula. To find our zeros. The quadratic formula says that x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So we can go ahead and just plug numbers into here. Now you'll remember that the quadratic has a general form of y equals ax squared plus bx plus c. So this is going to be our a, this is going to be our b, this is going to be our c that we're plugging into this quadratic formula. So we plug these in. Opposite of b is just going to be 12 plus or minus the square root of b squared, so 12 squared minus 4 times a, which is 1, times c, which is 1, all over 2a which is 1. All right, so we're going to have 12 plus or minus the square root of 144 minus 4 all over 2, which is going to equal 12 plus or minus the square root of 140 all over 2. And then we can factor 140, so that would be 2 and 70, 2 and 35, and 5 and 7. So we've got a pair here, so we can pull that on the outside of the radical. So we'll have 12 plus or minus 2 square roots of 5 times 7, which is 35, all over 2. Then we can split up our fractions. We've got 12 over 2 plus or minus 2 square roots of 35 over 2. We can reduce these fractions. 12 divided by 2 is 6, plus or minus. These 2's will cancel, the square root of 35. And that would be your zeros right there. So you would get x equals 6 plus the square root of 35 and 6 minus the square root of 35 as your 2 roots for that problem. So go ahead now and try on your own. F of x equals x squared plus 5x plus 4. And you're going to find the roots. So go ahead and pause the video now. Work it out on your own and check your solution with number 3 in the PDF below. All right, so that pretty much covers it for finding roots of equations. Again, we're just finding the location where it's crossing the x-axis, and where it crosses the x-axis, y equals 0. So we're going to plug 0 in for y into our original equation and solve for x.